Let's talk about geometric sequences. So a geometric sequence, you can think about it as a sequence of numbers where if you want to get from one term to the next term, you're going to have to multiply by a specific number. So you're going to have to multiply by a specific number. In this case, our sequence is 1, then 2, 4, 8, 16. So to get from the first term to the second term, I would multiply by 2, right? To get from the second term to the fourth term, I would multiply by 2, and so on, right? So the number that you're multiplying by to get to the next term, this is something we call the common ratio, all right? This is called the common ratio. So in this case, right, we're multiplying everything by 2 to get to the next term. So in this case, 2 would be our common ratio. Another way you can think about it is if I took any one of these terms, so let's say I take 8, and then I divide it by the term before it. So I divide it by the term before it. So term before 8 is 4, right? The thing before 8 is 4. 8 divided by 4 is 2. Let's say if I took another random number, let's say I took 4, and I divide it by the term before 4. In this case, that's 2. Notice how I also get 2. So notice how, right, the ratio from the term, like a term to like the term before it is 2. This is why this 2 right over here is called the common ratio, because if you take one random term, you take the term before it and you divide it by it, right? So in this case, we divided 8 by the term before it. Well, we're going to get a common ratio, right? And then this works for every term besides the first term, because, there's no terms behind that. But, this works for, let's say if I have this sequence right over here, right? So our first term is going to be -1. And the way you denote the first term is a sub 1, okay? So if I was referring to the first term, I could refer to it as a sub 1. This right over here, this 3 represents the second term, so I could refer to it as a sub 2. The third term, a sub 3. This is just the notation used to denote kind of the first term, the second term, the third term, and so on. So if, let's say this sequence goes on forever and it gets to the nth term. So this right over here represents, let's say, the nth term, for example. Just making a random n to represent that. But if this represented the nth term, well, you can denote this as a sub n, right? Just how the first term is denoted as a sub 1, if I have the nth term, well, I can denote this as a sub n, right? So that's just like some notations you got to know. At this point, it might not seem clear to you that this is a geometric sequence, right? Well, what you have to realize is that in a geometric sequence, your common ratio, so the number that you multiply by to get to the next term, that number can also be negative. So in this case, if I multiply -1 by -3, I get to 3. If I multiply 3 by -3, I get -9. If I multiply -9 by -3, I get positive 27. So whenever you see a sequence where the sign changes from a positive to negative, or negative to positive to negative, so the signs keep changing, well, what you're essentially doing is you're multiplying by a negative number. You can also have a sequence like this. So this right over here is our first term, a sub 1. And what's our common ratio in this case? Remember, our common ratio is the number we multiply by to get to the next term. So 9 multiplied by what number gives me 3? Well, 9 multiplied by 1/3 gives me 3, right? So remember, common ratio is the number you multiply by to get from one term to the term after it. So 3 multiplied by 1/3 gives you 1. And when you're dealing with common ratios, it's always the number that you multiply by to get to the next term. It's never the number that you divide by to get to the next term. Some of y'all might have thought, in order to get from 9 to 3, I have to divide by 3, so our common ratio must be 3. But y'all got to remember, common ratio always got to multiply, okay? Whenever you're dealing with common ratios, it's always the multiplication of one thing to get from one term to the next. So that's also something that's important. And your common ratio in this case is a fraction. So yeah, that's another thing that you kind of have to get used to. It might seem weird, but that's how it is. Say if I have this sequence, and I wanted to find the 8th term of this sequence. Well, how would I do this? Well, so right here we have our first term. One thing we can do is we can kind of manually do this, right? So in this case, what's our common ratio? What number do I have to multiply 4 by to get to the next term? Well, that's going to be 2, right? And then that's going to be true for all the terms. If the common ratio is true for one term, then it has to be true for the other terms. Otherwise, it wouldn't be the common ratio, right? It would be a common ratio. So notice how I'm multiplying every term by 2, right? So this would be the second term, this would be the third term, and so on. Now, if I wanted to find out the 8th term, aka a sub 8, right? A sub 8. Well, I could kind of figure out the pattern on my own, right? So I have 64, then the next term would be 128, because 64 times 2 gives me 128. So 128 would be a sub 6. Our next term is just going to be 128 multiplied by 2. That's 256. That's going to be a sub 7. And then if I multiply this by 2, I'm going to get 512, my bad. 512, that's going to be a sub 8. So our 8th term is 512. Now, all right, that might seem like a good strategy at first, but what if the question was asking us, for example, the 38th term? I do not want to do all this work. So how would we do this problem? How would we do this problem without actually having to do all of this manual work, right? This work's annoying. How do I find like a shortcut to this? And luckily for you, there is a formula. Sub n, which represents the nth term, is going to be equal to the first term times the common ratio to the nth power. The n represents your location of the term, and then minus 1. So in this case, if I wanted to solve this problem without using this annoying strategy, what I would do is, first of all, I'm trying to find what term am I trying to find? I'm trying to find the 8th term. So it's going to be a sub 8, that's the term I'm trying to find, is equal to the first term, what we saw here, the first term is 4, times the common ratio, we said our common ratio was 2, to the n minus 1 power. Now, n just represents the location of your term. So in this case, if we wanted to find out the 8th term, well, you can think about it as, well, our term would be located at area number 8, right? So the location of our term would be at the 8th spot. I guess you could think about it like that, right? The number n should match up the n in the a sub n. So in this case, if we're trying to find the 8th term, well, it's going to be located at the 8th spot, right? And then minus 1. You can use a calculator for this. 2 to the 7 is 128. 128 times 4 is going to be 512. And notice how we get the same answer. Let's do a slightly tricky. Okay, so looking back at our formula, what we need is we need the first term, we need our common ratio, and we need the location of our term. So in this case, our first term, well, that's obviously just 32. Well, what's our common ratio? Our common ratio, well, what number, you can think about it as, so what number multiplied by 32 gives me 8, right? So 32 times some common ratio is going to give me 8. What is that common ratio? If I divide both sides by 32, I'll just get my common ratio. Remember, our common ratio, we can actually find this out by dividing one of the terms by the term behind it, right? Which is what we have here. We can take out one of the terms and we just divide it by the term behind it so that we get this common ratio. So we get r is equal to 1/4. So our ratio is going to be, our common ratio is going to be 1/4. I'm just going to write equals r. And we're trying to find the 48th term. So the location of our term is going to be at spot 48. We got all of the supplies for our formula. So let's just plug it into the formula. So if you remember, our formula is going to be the first term, so in this case 32, times, it's going to be times the common ratio, which we said was 1/4, right? To the, well, where's our location of the term? 48. And don't forget the -1, right? So it's the n-1 power, remember? And, so 48 minus 1, that's just 47. Now what we have to do, just plug this into the calculator, you know what I'm saying? So 1 over 4 to the 47th power, that is a very small number. Multiply this by 32. I got 1.61, let's just round like this, 1.62 times 10 to the -27th. It's a very small number.